can LED grow light beat legacy HPS? So this is the $1,000,000 question, right? We're trying to answer in today's presentation. And basically, I'm going to make a case, obviously, to say that LED lighting can actually beat the HPS. And to give you some detailed information, we're going to start with the three countries, to be precise. We're going to start with Spain, Netherlands, and Sweden. Why are we doing that? Because Sweden and Netherlands, they are in a high altitude region. Spain is in a low altitude, so as far as sunlight's concerned, Spain is obviously going to get more sunlight than Netherlands and Sweden, right? So sunlight is extremely important to make, a more hospitable environment for plant growth. And when the sunlight or the daylight integral, when the amount of light that hits the greenhouses, when it's low, you do need something to supplement it, right? And that's where LEDs can come and step in. So this graph here basically talks about, Spain getting more light, and you can see right there, if you want it to be more refined, we can go to this page and we can compare tomatoes as an example. So tomatoes are crops that need at least 12 hours of light, every single day. It's important for them, right? But if you look at this bar graph, you can see that maybe from April all the way up to September is when you get what you need, or maybe even less. But the remaining months are pretty wide open in terms of not getting any light. So for sure, we do need something that can help with this, right? If I can think of anything, that's just LEDs all the way. So this is one of the reasons why, supplemental lighting is implemented, and you can see a picture of the greenhouse right there with some LED lights on. And we'll just get into a little bit of details on why one needs to pick LEDs over HPS. But what are the 4 factors to consider for greenhouse lighting, basically? So first, obviously, it's low cost. I'm going to be very careful with this because I'm going to say low overall lighting system cost. And I'll explain this in the upcoming slides. Of course, the initial cost of LEDs may be a little bit higher, but over the span of 5 years, you're going to see that LEDs are going to basically overtake HPS, and be aggressive on the pricing when you compare the replacement costs and energy costs that involves with HPS. The second one is obviously energy savings. We all know that LEDs are the most efficient technology available in the market, and they consume less power. So same light for lesser power, hey, who doesn't need that, right? So balanced growth, that's important. So you need to be able to control and tune your spectrum, right? But HPS just offers one spectrum. LEDs can offer multiple spectrums. Samsung has a lot of products. For you all who are in the booth, please check our booth today. We have some exciting stuff right there. But HPS does not offer the tunability for sure. Robustness, that's something we thrive on. And Samsung has a lot of technology that we put into a lot of resources on improving our reliability. The greenhouses have a lot of sulfur and humidity, so LEDs need to withstand those harsh conditions. And we have products that can do that I'll be talking about. So this is basically a summary of what I'm going to talk about in the upcoming slides. But right now I'd like to get into the details. So when looking at LED lighting, right, people have 2 options basically. You have the narrow spectrum and then you have the full spectrum. As the name suggests, narrow spectrum has 2 wavelength peaks. Basically, you see a peak in the blue, you see a peak in the 616 nanometer region. And on the right side, the big difference there would be the full spectrum has a lot of green. And when there's no sunlight, this can really help because green has a lot of benefits. Sun does offer a lot on the green space. So while there are theories, backing the narrow spectrum, saying that green may not be required, green is extremely important for plant growth for reasons that I'm going to talk about in the upcoming slide. And the answer is right there. So LEDs have the highest lifetime. It's 50,000 hours. when compared to HPS, which is less than 20,000 hours. So this is where replacement actually comes into play. So you need to replace the HPS more often than what you would with LEDs. And that's this chart basically is that's what it's trying to say, right? So when I look at this chart, and if I was building a greenhouse and I have this chart in front of me, I'm trying to pick an LED, or I shouldn't say LED, but I'm trying to pick a lighting source, um, and I'm looking at HPS. What would be in its favor? Low lighting system cost, right? And good visibility. So these are the two things that I can see in this list that actually backs HPS. However, in the upcoming slides, we'll see lifetime over 5 years, which will do more justice towards the LEDs. So let me, make sure you all have this slide in mind and go to the next one. So before we move on to the cost structure of HPS, I'd like to talk about a couple of things that might be helpful or that might be quite important, might not be related to cost or efficacy, but you can see here that basically I'm having narrow spectrum and full spectrum right next to each other. Narrow spectrum is purple light basically with blue and red peaks. And it's quite difficult to work under a narrow spectrum for humans basically because the purple light makes it difficult to identify any kind of diseases, and you're going to have a difficult time standing there for 8 hours, 10 hours, how much of a time you need to be there, right? But full spectrum is basically just what we have right here. It's lights that we see, and it's pretty easy to identify any kinds of defects in the plants. That's one thing. Environment is quite important for sure. So you have narrow spectrum and full spectrum right there. You can see that narrow spectrum, in terms of LEDs, they do emit purple light, and it causes a phenomenon called as purple light, which is classified as pollution. Full spectrum on the right side does not do that, so that's another advantage towards the full spectrum. All right, so it is all of the above, and this slide basically talks about those surprise questions on the previous slide. Photosynthesis, enhancing photosynthesis is quite important. It's done by sunlight. Having a narrow spectrum and not having any green, you can still grow plants out of it, but green is necessary for sure. Anti-disease, absolutely. You want the crops to be as healthy as possible. So green offers that, and that's quite important. Bioactive components. So you need the plants to be, as nutritious as possible. You don't want any lack of nutrition on what you eat, right? So bioactive components and the green helps with that, and that's the answer to the previous question, basically. Right. So let's look at some experiments that back this theory. So we're going to focus on the narrow spectrum and full spectrum. And once we talk about the LED solutions, we're going to go to the HPS and compare costs. So this is an experiment that was done in Seoul National University. You can see here that the cell structures in the full spectrum are more deeper, and this really helps with photosynthesis and nutritional aspects of the plants, right? And another experiment that we did, this is really interesting. So we set up a greenhouse basically with no supplemental lighting, just the sunlight. We put in HPS as supplemental lighting, put in narrow spectrum LEDs, which is just the red and the blue peak. And then we had the white-based full spectrum LEDs. So it's difficult to tell from this image on which one's better. Obviously, I'm going to go for the full spectrum LEDs because I know that there's a bar graph on the next page that actually gives you stats and numbers that can back that. So no supplemental lighting compared to white-based full spectrum LEDs, we're able to see a 71% increase in yield. So that's without any supplemental lighting, so it may not be fair enough to the other technology. So let's go to HPS, which is commonly used in today's technology. So compared to HPS, we're seeing about a 42% increase in yield with full spectrum. So that presents a strong case for the full spectrum. Obviously, the cost is quite important. So LEDs have two kinds of solutions, as you can see here on this slide. We have the narrow spectrum LED, and we have the full spectrum LED, right? So two solutions. But you can actually see three graphs. So why do we have three graphs? Well, the reason why we do that is because we understand and acknowledge that LED solutions, the initial investment is high, right? So we want to try and reduce the initial investment as much as we can. It's still going to be a little bit higher than an HPS. So let's look at the two graphs or the two lines that has the full spectrum. You have the dark blue and you have the light blue line. So the dark blue is LH 502H-D. That's our new 50/50 LED that we're launching, and that combined with red can give you a reasonable price to start with. As you can see there on the left side of the graph. And then you have a more efficient solution on the right side, white-based full spectrum 301H LEDs. So 301H is one of our most popular LEDs available, and it has extremely high efficacy, high resistance to sulfur, which is the need of the hour in greenhouses. But HPS cost is low. Just if you see the number 0 and you see the dotted line, that's where the cost starts. But let's travel to the future. 1 year, 2 year, 3 years, all the way up to 5 years down the line, that dotted line is way up there. So why is this happening is because you buy HPS at a lower price, you do pay more electrical costs, and the lifetime is lower, so you're going to have to replace it. LEDs, on the other hand, you pay a little bit higher upfront, and then as you move forward, you do not need to replace it more often, and you save every single month on power consumption. So it makes sense for everyone to start switching to LEDs. While I understand that the initial cost is attractive, over time you're going to spend more, which is basically hidden in the background. So we just wanted to point that out here, just to bring awareness to that fact. Right. So that's a nice comparison again that we have, basically trying to put it in a bar graph on whatever I talked about on the previous slide. So let's look at the blue rectangle right there. Lighting energy is extremely high, and that kind of compares it with the darker blue rectangle on the right side. We can see that white-based full spectrum LEDs, doesn't matter if it's 301H, doesn't matter if it's 502H, those two are equally good in energy consumption. They consume less power than a typical HPS. In terms of cost, please look at the gray area in the bar graph. HPS cost may be low, but full spectrum is a little bit higher. But the overall cost over 5 years has come down. So basically the same graph as the previous page, but in a bar graph format. Right. So this is a good scatter plot to have. We're basically trying to say is that DLC has enforced a requirement of 1.9 for you to get rebates. So you need to be at least 1.9 micromole per joule or above. HPS is barely hitting that mark, right? It's 1.8 micromole per joule. So that itself is a good start right there to change to LEDs if you want rebates. And the rebates are also in terms of power consumption. So you can see right there, but this is basically showing you wide range of possibilities of narrow spectrum and full spectrum LEDs. Starting from, you could hit 1.9, or you could go all the way up to 3.6, depending on your requirement or efficacy requirement. All right. So we talked a little bit about robustness of LEDs. And in this slide, I'm going to focus on 502H-D. That's our EPI solution. It has bond wires, and the bond wires need to be protected from sulfur and humidity, and so does the whole LED. So Samsung has developed a special protective coating that we put on our 5050s. So you can see right there on the right side. And when the harsh gases like sulfur, when they come in, the protective coating really helps to enhance the lifetime. So this is from our new 5050 50H-D. So if you're here and you want to check the product out, please come to the booth, or some of this will be posted online as well for your future reference. All right, so let's talk about this for a couple of minutes, because I feel like this is extremely important. So especially for someone who's trying to, build fixtures for greenhouses, who's not familiar with Samsung LEDs, all you need to do is have this chart printed out, and that's a good start right there. So I want a fixture that's 2.4 micromole per joule efficiency. That has an efficiency of 2.4 micromole per joule. What products do I pick? Because Samsung's huge on its product portfolio, starting from 3030s all the way up to 3535s. So I'm going to look for 5 stars. That's what I need, 5 stars. So 2.4, I'm scanning through that list in the middle right there, and I'm looking at 5 stars in the 50-50 area, right? So 50-50 would be the best solution for me to get the maximum performance out of it at a reasonable cost. Another example would be 3.0 micromole per joule, which is a huge number in the market. Everyone wants to get there. Well, we can help. The 301H Evo Mint White can actually help get there. So that's a good chart to have, and I'm sure these ones would be posted in YouTube as well. And I urge you all look at it for future reference. Right. So that's to summarize our product line, and you can see we have wide range of products, 301H, all the way to the right, and we're continuously making improvements to improve the efficacy any way we can, and not only improve the efficacy but help you improve the yield. At the end of when you build fixtures with our LEDs. Right. So one of the important aspects of our products, I like to talk about CSPs for sure, because I feel like this is the future. So shadowing has been a little bit of an issue with greenhouses in the past, and CSPs are a chip scale package LEDs. They're extremely small, and when compared to 3535s, you can see here that the form factor of the whole board can be reduced. The size of your heat sink can be reduced, and so does the cost of your fixture. So please take a look at our CSPs as well, and it can help avoid shadowing in greenhouses. All right. So let's summarize the whole presentation. Why would I use LEDs over HPS? LEDs consume the same amount of power or even less for more light output and more efficacy. Right? LEDs have 42% more growth than HPS, and you do not need to replace them just like what you have to replace HPS every 2 years, 3 years. You do not have to do that with LEDs. So initial cost may be high. The cost over 5 years is definitely low.